Yeah, good morning, everybody. Can you listen to me? Please raise your hand. Yes, everybody, please raise your hand. Good morning. Okay, see, quick review what we did yesterday. Everybody, just observe a quick review of what we did yesterday. Okay, now see here, sir. Last class, we were continuing that cube problem. But in this case, we are asking RAC. RAC is the opposite diagonal corners of one of the surface. Here, path resistance in all paths are not equal, so we cannot do current division and apply KVL. RAB, like what we did previously, was opposite diagonal corners of the entire cube. There we did that symmetry advantage of current division. But here, another idea is, first I express this as a planar mirror image network. From that, I identified which nodes are at same potential. So I joined it. Okay, and then the circuit became very simple. So we took two things in advantage. First, symmetrical planar and joining such nodes which are at same potential. Okay. Then RAD also, after making it planar and mirror image, identifying such nodes which are at same potential and joining them to simplify faster. Then such applications which came in gate, I gave some examples, IES bit, gate bit. Here resistors are not equal, but path resistance in all paths are equal. Okay. And this is also gate bit for EC. Very, very interesting bit, sir. Then I went to infinite grid problem. Now in this infinite grid, we cannot apply the ladder concept, which is not accurate. Mirror image, current division also not possible as path resistance in all paths are not equal. So we applied superposition. In the first step, I injected current at T and collected at infinity. And because of that infinite node, the path resistance in all paths are equal, then a current division was possible. In the second case, I injected current at infinity and collected at B. Then also the path resistance from B to infinity in all paths are same. So the current convergence was observed. Now, according to superposition theorem, injecting at A and collecting at infinity, injecting at infinity and collecting at B is nothing but A to B, and that voltage is VAB. Now, according to superposition theorem, sum of individual effects is total effect. So I added this. So we got VAB dash plus VAB double dash. We got the answer. Then resistance is Ohm's law, that is VAB by I. Then dependent source problem. Now remember, dependent source problems will have some internal subcircuit resistance which we should include. Okay, which we should include and then argue. So in such case, reduction is not possible. So we applied Ohm's law. Here also gate bit where there is a current dependent current source. Then effective resistance. Effective resistance is working resistance without any disturbance or without any change in the network. Then what is the effective resistance seen by the voltage source? Okay, what is the effective resistance seen by the voltage source? Please understand this, effective resistance seen by the voltage source. Okay, here also Ohm's law we did because reduction is not possible. Then we started DC basics. This is module 3 of chapter 1. KCL, KVL basics. Okay, this is also KVL basics. Current division rule, voltage division rule, open circuit, short circuit definition, conductance problem. Okay, conductance problem. Then here also Ohm's law and KVL, Ohm's law and KCL. Okay, such basics we did. Okay, na? All such basics we did. Okay. Chalo, sir. Now let us continue further. Okay, everybody, let us continue now. I'm going to the next model. Everyone, please quickly take rough papers, pen, pencil, and do it, sir. Notes we are already sharing with you. Don't worry about it. So doing the problem along with me is very important. So here the question is, find current I. Three ohm, 6 ohms, 1 ohm, 2 ohm, 3 ohm. Now this is something like 56 amperes. And I want the current in this 3 ohms branch, current in the 3 ohm branch. Another question I'm giving, find power delivered by dependent source. Find the power delivered by dependent source. Okay, find the power delivered by dependent source. Chalo, do these bits 1 minute only. First question, find current I. Second question, find power delivered by the dependent source. Everybody 1 minute only, sir. Let us do a lot of problems today, but only 1 minute each time. See, all our first IES, Genco, such bits, sir. Gate bits also I will do, but simple bits, so it should not take more than 30 seconds. Find current I and power delivered by the dependent source. Yes, it's time over. Chalo. No, sir. Today we will do a lot of problems aggressively. Now listen, sir. If you are doing, do it fast. See, actually here, how many nodes are there in the left network? How many total nodes? Actually, there are only 2 nodes, please. See, this is one single node and this is one single node. See, there are only 2 nodes. See, this is one single node, this is one single node. What is the degree of this node? Degree of this node is 6, not 3, because these are parallel. See, 1, 2, 3, 4, 5, and 6. See here, don't just see here and declare it is degree 3. Actually, there are 6 branches connected here. 1, 2, 3, 4, 5, 6. So degree of this node is 6. And here also, what is the degree of this node? Don't just see this 3 and declare. See here, you see these 2 are parallel. 1, 2, this current source 3, and these 3 parallel 6. So this is a single node with degree 6. This is another single node or principal node with degree 6. There are only 2 nodes. Actually, all are parallel, sir. Between these 2 nodes, all branches are parallel. So current division rule. See, my target branch is this 3 ohms now. Now, rest of the non-target elements, I will lump them because they are all parallel. See, rest of the non-target elements, I will lump them. See, 3 in parallel to 6, 2 in parallel to 2, 1 in parallel to 1, half ohm. Okay, na? See, non-target elements, if I lump 6 in parallel to 3, 2 parallel, 1 parallel, half. Now there is a current division between this half ohm and 3 ohm. Now there is a current division between half ohm and 3 ohm. Okay, current division between half ohm and 3 ohm. Okay, na? So now in that regard, everybody now in that regard, now there is a current division between half and 1. But practically this current will come. Yes, practically this current will come. First it will divide into 2 branches, then again it will divide into 3 branches. So this current is opposite to my direction. Na? Yes, current is opposite. Practical current is opposite to asked reference direction. So answer should be negative. So this current is negative. First negative, why? Because actual current is opposite to reference. Practically current will go, divide and come back. So this practical direction is opposite to reference. So negative. Now current division rule. Total current 56 into opposite. What is opposite? All the remaining branches, non-target branches, which I lumped into half ohm by sum. Sum is 3 plus 1. Okay, 3 plus 1. Okay, so minus 56 into 1 by 2 by, okay, 7 by 2. So answer is minus 8 amps. Chalo sir, answer is minus 8. Okay, current division rule. Why? Because now they are all parallel. Okay, na? Chalo, now see, power delivered by the dependent source. Now to find the power delivered by the dependent source, I need voltage across it and current through it. Okay, now to find power delivered by the dependent source, I need voltage across it and current through it. Now, because it is a current dependent voltage source, because it is a current dependent voltage source, happily I am writing a KVL. So if I write a KVL, yes, it is write a KVL minus 10 plus 2 I naught plus 3 I naught equal to 0. So automatically I naught is 2 amperes. I naught is 2 amperes. Now once I naught is 2 amperes, yes, this is the same 2 amperes flowing. Now this is 3 2s are 6 volts. So we got I naught, and from that I naught, because it is a current dependent voltage source, we got this also. But see here clearly, here current is entering the positive terminal. Current is entering positive terminal means it is sink. It is sink. But can sink deliver power? No, he asked na. So power delivered, sink cannot deliver. So minus off. You have to put minus voltage into current. Answer is minus 12 watt. Okay na? See, first problem is current division because all are parallel. But second problem, there is a current dependent voltage source. But to find power, I need both voltage and current. But unfortunately, current is entering the positive terminal of element. It is a sink. So power delivered is negative. Power delivered is how much? Negative. Okay. Now here another question. What is V naught? Okay, everybody. Next question you have to do, please. And I am asking what is V naught? Okay, na? Yes, the question is what is V naught? (24 volts, 2 ohms, 1 ohm, V naught, V naught by 2. Okay, here what is V naught? Okay, now everybody, what is V naught? Then I'm giving another interesting question, very, very interesting question here. Okay, these models are also important. Here also, what is V naught? What is V naught? Okay, chalo. Both the problems find V naught. Quickly, only 1 minute. Yes, everybody, I'm doing the problem now. See, left side there is a problem with only single mesh, and moreover there is a voltage dependent voltage source. Okay, na? And I want V naught. V naught is a voltage across 2 ohms actually. V naught is the voltage across 2 ohms, but that will affect the value of the dependent source. Now, sir, here you see, first I will apply Ohm's law. What is Ohm's law? I is V by R. I is V by R. Now, in a passive element, current should enter positive. Na? In a passive element, current should enter positive. Okay, V by R, that is V naught by 2. I is V by R. Okay, na? And then happily I will write a KVL. If I write a KVL, minus 24 plus V naught plus V naught by 2 plus another V naught by 2 equal to 0. 2 V naught is 24, V naught is 12 volts. V naught is 12 volts. V naught is 12 volts. Okay, now V naught is 12 volts. Now here also I require V naught. Everybody, here also I require V naught. But to get first I naught. Now these are independent mesh. See, these two meshes are independent to right side. These two meshes are independent. See here, this left side part and right side part are not electrically connected. This is a network concept where networks are, yeah, I can say circuits are building blocks of network. See, these two are meshes together. This is one mesh, but this left side and right side are independent to each other. So this is one circuit, this is one circuit, and this is a network. Okay, circuits are building blocks of networks. Now, sir, first, what is the total resistance seen by the source? 3 in parallel to 6 to 2 plus 2, 4. Okay, 60 by 4. This is totally 15 amperes. Now 15 amperes will divide here. Now I naught. So this 15 amperes will divide in two branches because these two are parallel. So this I naught will be total current 15 into opposite 6 by some 9. So this is 10 amperes. Now once I naught is 10, this becomes 80 volts. Now this current will go only this side. Now the resistance in by this 80 volts is 10 ohms. So this current automatically is clearly how much? 8 amperes. 8 amperes. But in a passive element, if current is going upward, in a passive element, if current is going upward, so this should be positive, this should be negative 8 5 of 40 na, but our reference is ulta to practical. So V naught is minus 8 5 of minus 40 volt. Okay, simple problems are observed. See, first of all, this left side part and right side part are not electrically connected, but left side part are independent meshes, and this is also, sorry, left side part are two meshes together, but right side is a single mesh. Now these two meshes and right side mesh are called independent meshes, independent. Because no current, see, because no current can flow through this wire, because there is no closed path. See here, no current can flow through this wire. It is only a formality to give like that. It is only a formality to give like that. So the only resistance in by 60 is 2 plus 3 in parallel to 6, 4. 60 by 4, 15. Current division 10. Now this is 8 I naught 80. Then resistance in by this is 10. So 8 amperes anti-clock. So 8 5 of 40. But the given reference polarity and practical are opposite. So V naught is minus 40 volts. Okay, now V naught is minus 40 volts. Okay, now please understand that. Okay, V naught is minus 40 volts. Okay, now I'm asking another question, everybody. Yes, I'm asking another question. What is Vx? This is a gate 1 mark bit, please. Yes, this is a gate 1 mark bit. What is Vx? Not so big, not so tough. Fundamentals. So what is Vx? What is Vx? Tell everybody gate 1 mark bit. And another question. Power delivered by dependent source. By dependent source. Four V naught arrow downside 2 ohm Om, and this is V naught. Chalo. Power delivered by the dependent source. Okay, now power delivered by the dependent source. Okay, power delivered by the dependent source. Okay, everybody, look at the left network. See, in the left networks are actually there are two independent sources and one dependent source. Generally, it looks complex. Like there is an independent DC voltage source and there is an independent DC current source and there is a voltage dependent voltage source. Generally, everyone feel it is a complex network. Yeah, in case you are not getting any idea, then use mesh analysis, nodal analysis, which I will teach you also. But sir, simple fundamentals will save you a lot of time. What are simple fundamentals like Ohm's law, Kirchhoff's law, etc.? Now listen, I will just apply such fundamentals. Now this is Vx is the voltage across 1 ohm. Vx is the voltage across 1 ohm, but this Vx is a dependent parameter which will affect the property of this dependent source because there is a voltage dependent voltage source. There is a voltage dependent voltage source. So first Ohm's law. Now, if this is Vx, this is 1 ohm. If this is Vx, this is 1 ohm. What is this current? I is V by R. I is V by R. This is Vx amperes. Okay, this is Vx, this is 1 ohm. And I is V by R. This is Vx amperes. Now, this is Vx, this is 2. Okay, this is Vx, this is 2. So, this is Vx plus 2 amperes. Okay, Vx plus 2 amperes. That is KCL. Because this is Vx, this is 2. That is Vx plus 2 KCL and then KVL. So, KCL plus KVL. Now, if you write minus 10 plus Vx plus 2 into Vx plus 2 plus 3Vx equal to 0. So minus 10 plus Vx plus 2 into Vx plus 2 plus 3Vx. So overall 6Vx is 6Vx is 1 volt. See sir, how interesting is this? Okay. So now see the right side problem. See the right side problem. Power delivered by the dependent source. Again, to find the power delivered by the dependent source, I need voltage across it and current through it. But what type of dependent source is this? This is a voltage dependent current source. Now, first of all, between these two nodes, everything is parallel. Okay, between this top node and bottom node, all are parallel. So voltage is same. So if this is 10 volts, obviously this is also 10 volts. Okay, obviously this is also 10 volts. Now 10 volts across this V0, 10 volts across these two resistors in series, I can do voltage division rule. Okay, but see, when this 10 volts is across here, actual current will enter this side now. Actual current is enters this side. Yes or no? That is 10 by 5, 2 amperes. Okay, 10 by 5, 2 plus 3 is 5, 2 amperes. Because upper terminal is positive when compared to down. In a passive element, current enter positive. So 10 by 5 is 2. But actually, when current is entering this side, in a passive element, this should be positive. When current is entering from the top, this terminal should be positive, but it is ulta. So V0 is minus I into R. So V0 is minus 6 volts. V0 is how much? Minus 6 volts. So once V0 is minus 6, once V0 is minus 6, this is minus 24 amperes. Yes or no? See, when V0 is minus 6, please understand, when V0 is minus 6, this is minus 24 amperes down. Now, minus 24 amperes down, listen carefully, minus 24 amperes down, I can make it 24 amperes up. Yes, minus 24 amperes down, I can make it 24 amperes up. 24 amperes up. Okay, na? Yes, I can make it 24 amperes. Now clearly here current is leaving positive terminal. Here current is leaving positive terminal this source. Current is leaving positive terminal source. So power delivered is positive voltage into current. It is plus 240 watts. Plus 240 watt. Okay, plus 240 watt. Okay, na? Plus 240 watt. Okay, because it is source now. Finally, see, because minus 24 amperes down means 24 amperes up. That is the meaning. And finally, current is leaving positive terminal. It is a source. Power delivered is positive. Okay, power delivered is positive. Okay, now I'm extending further to go more classical problems here. Yes, more classical problems here also. Yes, this is a very interesting question. Here I need V0 and as well as I0, both V0 and I0. Very interesting, simple problem. $90 volts, 3 ohms, 6 ohms, 2 ohms, 2 ohms. I need this V0. Okay, and I need this I0. Okay, I need V0 and I need I0. Okay, I need V0 and I need I0. Okay, similarly, this is a gate bit. Next bit I'm giving is a gate bit. Next bit I'm giving a gate bit. What is R? This is 10 amperes. This is 5 amperes. I need R. Okay, I need this R, resistance R. Okay. R. Okay. See, in the left question, I need V naught and I naught, and the right question, I need resistance. That is a gate question in 1 mark. So, quick, sir, fundamental thinking, basics. I told this is simple things, basic DC circuit analysis we are learning. Yes, here again, see everybody, I need V naught and I naught. Okay, see how I will do, you see. First, see everybody, what I'm doing, just observe. See first here, everybody, Now this 3 and 6 are parallel. See, between this node and this node, this 3 and 6 are parallel. So 3 and 6 parallel, I will lump it becomes 2. And again between this node and this node, 2 parallel, again I will lump it as 1. Okay, now first understand that is our reduction concept. See, between top node and this middle node, 3 6 parallel, 18 by 9 2. And this between these two parallel 1. So from source point of view 90 volts, from source point of view 90 volts, it is like 2 ohms and 1 ohms are series. Yes or no? After simplifying the parallel elements into single element, now from source point of view, these two are series. Yes or no? From source point of view, when these two are series, I can do voltage division rule. Then what is this V0? This V0 will be total voltage 90 into same by sum. Same by sum. Same is 2. Sum is 2 plus 1, 3. So it is 60 volt. So clearly V0 is 60 volts. Because they are parallel, our voltage will remain same. So now I can confidently write this is also 60 volt. Okay, this is also 60 volt. Now out of 90, if 60 volt drop take place, then what is the remaining drop here? 30 volts. So again they are parallel, voltage will be same. So this is 30 volts and this is also 30 volts. This is also 30 volts. Now between this and this, okay, these two are parallel, between this and this, these two parallel. So out of 90, yes, this is 60 and this is also 30. Okay, now this is 60 and this is 30. Now once we got V0, now I will apply KCL to find I0. How? See now, this is 60 by 3. How much? 20 amperes. Okay, this is clearly 20 amperes. Okay, now this is 30 by 2. This is 15 amperes. 30 by 2, 15 amperes. Now if you apply KCL, so if you apply Kirchhoff current law, yes, Kirchhoff current law. Okay, if you apply Kirchhoff current law, incoming current is equal to outgoing. Incoming 20 is equal to outgoing 15 plus I0. So I0 is 5 amperes. I0 is 5 amperes. Okay, you can apply KCL here also, you'll get answer. So finally answers are V0 is 60, I0 is 5. Okay, V0 is 60 and I0 is 5. Now look at the right side problem. Very interesting. He want this resistance R, but he gave a lot of information, sir. See now, if you apply first KCL here, I will just apply KCL, KVL to find R. Now see, if you apply KCL here, see this side is already 10. Yes or no? Because he gave here 10. 10 is leaving this 100 volts. So this is 10. And this side already 5. 5 is leaving 40 volt source. This is 5. So if you apply KCL 10 plus 5, this is total how much? 15 amperes. Okay, once that is 15, yes, once that is 15, this is 15 twos are 30 volt. 15 twos are 30 volt. Now see, with respect to this as reference, if this is 30 and this is 100, this difference is 70 here across 14. And here also, if this is 40, this is 30, this difference is 10 volt. Now again, see, this is 70 by 14, this is 5 amperes this side, and this is 10 by 1, 10 amperes this side. Passive element current enter positive. Now out of 10, 5 and these are now out of 10, 5 and so this also has to be 5. Out of 10, 5 and this has to be 5. 5 plus 5, 10. So happily I can write a KVL. Actually, if you write a KVL, yes, if you write a KVL, everybody, yeah, starting from here, 5R plus 10 minus 70 is 0. 5R is 60. So R is 12 ohms. R is 12 ohms. Simple KCL, KVLs are there, fundamentals only. Okay, they are fundamentals like KCL, KVL only. Okay, now. So observe, sir, what I'm doing. There may be any other procedure you did, sir. Very good. Don't worry. See, suppose you did something better than this or something more comfortable. Very good, sir. Continue like that. Okay. No need to do the same way I'm doing. Whatever way you do, but answer should be unique because it is a numerical subject, na? Okay. So here also simple KCL, KVL. Here voltage division, Ohm's law and KCL. Here also first KCL, KVL like that. Okay. Such basic thinking if you get, then we can go for big things. Okay. Now, sir, here also what is V0 and what is I0? Okay. Here I am asking what is V0 and what is I0? So this is 4 volts. This is 8 ohms, 3 ohms, 6 ohms, 1 ohm. Okay, question is what is V0 and what is I0? Okay, and I'm extending this problem by modifying certain things. Yes, I'm extending this problem by modifying certain things. Here also what is V0 and what is I0? Okay, here also I'm asking what is V naught and what is I naught. So this is 8 volts, this is 8 ohms, this is 3 ohms, 6 ohms, 2 ohms. Okay, now this is I naught. Okay, this time this is I naught, and this will be 9 I naught, 9 I naught, and this is 1, and this is however V naught. Chalo sir, here also everybody given right side also what is V naught and I naught. Left side and right side circuits are slightly similar, but some important modification. Please observe and write the answer. So here also what is V naught I naught, right side also what is V naught I naught, but right side there is a current dependent voltage source. Chalo quick sir. Yes, everybody see here, I need V naught and I naught. Everybody, I need V naught and I naught. See, first of all, if you observe carefully, there is a short circuit across this 8 ohms that will not work, and there is an open circuit in series to 1 ohm that will also not work. So there is a short circuit across 8 ohms that will not work, and there is an open circuit across 1 ohm that will also not work. Now, clearly, what is the total resistance in by the source? 3 in parallel 6 to 2 plus 2, 4 ohms. So 4 by 4, this is 1 ampere. 1 ampere full short, this is also 1 ampere. Now, after coming here, 1 ampere. Now, this 1 ampere has how many parts to divide? Only 2 parts because this is open, it cannot go, this is short. So current division, if I do, this current will be total current 1 into opposite 6 by some 9, 2 by 3. And out of 1, if 2 by 3 1, this is 1 by 3. Out of 1, if 2 by 3, this is 1 by 3. Okay, na? 1 by 3. Okay. So now this is 2 by 3, this is 1 by 3. Now 2 by 3 into 3. Okay. Yes, this is 2 volt and obviously this is also 2 volt. Okay. Now V naught is directly 2 volts. Though there is an open circuit and current is not flowing, but voltage will appear. Because of this voltage, the material get polarized and voltage will appear, sir. See, voltage does not require any closed path. Current requires closed path. Current requires closed path, but voltage does not require anything like that. So V naught is directly 2 volts. So V naught is directly 2 volts. Okay, and I naught is 1 ampere. Okay, now V naught is directly 2 volts and I naught is 1 ampere. Is it okay? Yes, V naught is 2 volts, I naught is 1 ampere. Then what is the role of this 1 ohm? See, with this 1 ohm, no current is flowing and no voltage drop because it is not in a closed path. But this 1 ohm material gets polarized and voltage will appear. Okay, now here also, if you observe, yes, though there is a dependent source, right side problem, though there is a dependent source, but this is open and floating. Current cannot flow. And this 8 ohms is also shorted. Okay, now the only resistance here appearing is 3 in parallel to 6 to 2 plus 2, 4. Now 8 by 4, this is 2 amperes. This is 2 amperes. Now this 2 amperes will come here. Now it has got how many paths to divide? Only 2. So here also current division. This current is again total current into 2 into opposite 6 by some 9. Okay, so this is 4 by 3, 4 by 3 amperes. So first of all, I naught is 4 by 3. We got it. Now, if 4 by 3 is going here, okay, this is 4 volts. Then 2 by 3 will go here. That is also 4 volts. Now don't say V naught is 4 because there is a dependent voltage source. Now because it is a current dependent voltage source, and I naught is 4 by 3. Yes, when I naught is 4 by 3, 9 into 4 by 3. Yes, 9 into 4 by 3 is 12 volts. Still voltage across passive element is 0, but dependent source will still exhibit voltage because there is a current dependent voltage source and I naught is 4 by 3. This becomes, yes, 12 volts. Now I can write a KVL. So minus 4 plus 12 plus V naught is 0. V naught is minus 8 volts. V naught is minus 8 volts. Okay, now V naught is clearly minus 8 volts. V naught is minus 8 volts. Okay. So here I naught is 4 by 3 and V naught is minus 8. Okay, V naught is minus 8. Okay, now then I'm extending further. Yes, this is a simple gate bit. What is V naught? Okay, this is a network and this is 2 amperes, 3 ohms and 4 volts. Now carefully watch, I need this voltage across this box, V naught. But I'm giving interesting options here. I'm giving options. Option A, 4 volt. Then I'm giving IES objective. Yes, everybody, I'm giving IES objective. Okay. Here also, what is V naught? Here also, what is V naught? Here also, I'm asking what is V naught? Network A, network B. This is 5 ohms. This is 2 ohms. And this is 7 ohms. Okay. And this voltage is 10 volt. This voltage across 2 is also 10 volt. Okay. But I need voltage across this 7 ohm. 7 ohm. So observe both this, sir. In the left side circuit also I need V naught. In the right side circuit also I need V naught. Okay. Yes. Quickly, everybody. Quickly. Just 1 minute. Yes, everybody listen now. Here I need V naught. Okay, V naught is the voltage across this box. See, actually, if you see, okay, there is a current source in series to all these elements. Okay, current source in series now. This is 3 twos are 6 volts. Okay, there is a current source in series. This is 3 twos are 6. Now this is 6 volts and 4 volts. Okay, this is 6 volts and 4 volts. Until here, see, until here I can say it is 10 volts because 6 plus 4, 10 KVL satisfied. But without knowing the voltage across current source, you cannot say tell V naught. Please understand this meaning, sir. See, there is a network and there is a series branch, sir. And current source in series to both these elements. Current is constant. Yeah, current source in series to any element, current is constant. Other elements are called redundant because they will only incur losses or power absorbed. So this current source is constant. So this is 2 3s are 6 volts and 4 volts. Total 6 plus 4 10. But don't say V naught is 10 here because we still don't know the voltage across current source. That is data insufficient. There will be definitely some voltage across current source which I don't know here. So V naught is not possible. None. Very interesting get bit. Now right side ISC. Now, don't misunderstand. These are parallel connections, sir. No, this is a network A, network B. Inside connections, we don't know. Don't misunderstand. It is a parallel. It looks like that. Are everyone feel? Are this is 10 volts. This is 10 volts. It is parallel. He is cheating you actually. Don't say V naught is 10. Instead, apply KCL. Now, this is 10 by 5. This is 2 amperes entering. Here also 10 by 2. This is 5 amperes entering. So 2 amperes, 5 amperes, total how much? 7 amperes coming out. Okay. 2 amperes entering and 5 amperes entering. Total how much is coming? 7 amperes. But when 7 amperes is coming from right side, when 7 amperes is coming from right side, V naught is minus 49 volts. V naught is minus 49. Okay, when 7 amperes is coming from right side, V naught is minus 49 volts. V naught is how much? Minus 49 volts. Okay, now minus 49 volts. Okay, yes, V naught is minus 49 volts. Please understand. Okay, now. Now this is also gate 1 mark, sir. Here also what is V naught? Answer this carefully. Very interesting question. What is V naught? Okay, what is V naught? And this is gate again. If VA minus VB is 9 volts, then VC minus VD is how many volts? Okay, everybody. If VA minus VB is 9 volts, VC minus VD is how much? VA minus VB is 9 volts, VC minus VD is how much? If VA minus VB is 9 volts, VC minus VD is how much? Chalo, everybody quick. Yeah, now see this. He want voltage V naught in the left side circuit. Though he gave so many, see, though he gave so many components to confuse you, but to find V naught, I will write a KVL. To find V naught, I will write a KVL. See, sir, I will start from here. Like this, I will go. Now this is a voltage source, voltage source, voltage source, and voltage source. KVL, yes, KVL. So always write KVL in that path where voltages are easy. So I'm starting from here, everybody. So minus 10, minus 5, plus 7, minus 20, plus V naught is 0. Okay. Minus 10, minus 5, plus 7, minus 20, plus V naught is 0. V naught is, now this is 25, 10, 35, minus 7, plus 28 volts. Plus 28 volts. Okay, now? Yes, plus 28 volts. Okay, now see, though he gave so many things to confuse, yes, though he gave so many things to confuse, but V naught is 28 volts. Now see, here again, if VA minus VB is 9 volts, VA minus VB is 9 volts. VA minus VB is 9 volts, then VC minus VD. Now, though he did not give R, not necessary, sir, because if you observe carefully, this 9 volts across 3, this is clearly 3 amperes now. This is also 3. 9 by 3, 3. Okay, 9 by 3, 3. Now 3 will enter and 3 will come out. Yes, 3 will enter and 3 will come out. Okay, 3 will enter and 3 will come out. But here at this junction, 3 plus 1 total 4 amperes. Okay, na? But when 4 amperes is entering to 2, 4 amperes is flowing through 2, this is 4 2s are 8 volts. 4 2s are 8 volts. Yes or no? This is 4 2s are 8 volts. Yes or no? No, VC minus VD is 8 volts. VC minus VD is 8 volts. VC minus VD is 8 volts. Okay, na? That is the answer there. Okay. Now I'm going further. Yes, I'm going further. Everybody should understand this. I'm going further. This is again a gate bit. Yes, very simple gate bit. What is current I? What is current I? Okay, find current I. This is also a gate bit. Here find current I. Here also find current I. I need this current I. Okay, in the left side circuit also what is current I, in the right side circuit also what is current I. Quick, everybody. Yes, here again, if you see, I need current I in both cases. Now, first of all, if you apply KCL at this entire network also, see network also KCL. I told us our basics KCL is applicable in a node everywhere. See, if you apply KCL in the entire network also, incoming currents equal to outgoing currents now. See, this is 9. So this total incoming also should be 9. If outgoing is 9, incoming also should be 9. This is 3 already. Then how much this should be? 6. Yes or no? So 6 plus 3 only 9 will go here. Now I'll apply KCL at node level also. See, out of I, see, I need I actually. Out of I 9 went. Out of I 9 went. So this is clearly I minus 9. I minus 9. Now I minus 9 is added with 3. I minus 9 is added with 3. Okay, I minus 6. I minus 6. I minus 6 plus 6 is again I. I minus 6 plus 6 is again I. Now I'm writing a KVL. Shall if you write a KVL? Yes. 2 into I minus 9. Okay. Plus 3 into I minus 6. Plus 1 into I is 0. 2 into I minus 9. 3 into I minus 6 plus I is 0. So 6I, okay, 2, 3, 1. Okay, 6I is 9 to the 18, 18, 36. So I is 6 amperes. Simple KCL fundamentals. Okay. Now right side, sir. Right side is symmetrical. Now see, right side network is symmetrical. Right side network is symmetrical. Why it is symmetrical? Path resistance in all paths are equal. Now you go from here to here in any path. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. The path resistance in all paths are equal. Even mirror image also you can observe. See, even mirror image. Suppose I draw a line here. This side and that side are mirror images. Na? Yes. So path resistance in all paths are equal. So let me do first current division congruently. See, here this is x. Path resistance same now. This is x by 2. Okay, x by 2. Again path resistance equal. So x by 4. Again path resistance equal x by 8. So I'm writing a KVL first to find x. If I write a KVL, yes, if I write a KVL minus 65 plus x into 1 plus x into 2 by 2 another x plus x into 3 by 4, okay, plus x into 4 by 8 is 1 by 2 equal to 0. So if you observe this x you take common, okay, 2 plus 3 by 4 plus 1 by 2, okay, 2 plus 3 by 4 plus 1 by 2 is equal to right side this 65 will come. Now if you take LCM 4, 8, 9, 10, 11, 12, 13 equal to 65. So 13 ones are 13 fives are. So x is equal to 20 amperes. Okay. But I need what? But we need I. See the question. But we need I. Everyone look here. But we need I. I is in 3 ohms branch. But in 3 ohms branch, how much current will flow? X by 4. But I is x by 4. So it is 20 by 4. Answer is 5 amperes. Answer is 5 amperes. Simple, sir. Symmetry. Okay, na? Symmetry. Now I'm giving another interesting question. Yes. Okay. If R is equal to 2 ohms, then I is equal to 5 amperes. Now if R equal to 5 ohms, okay, then I is how much? Then I is so network A, network B, 10 amperes R 1 ohm, okay, and this is I, and this is I. Okay, if R is 2 ohms, I is 5 amperes. Now if R is 5 ohms, I is how much? Okay. Then another interesting gate question. I am giving another gate question. Yes. Serious gate question. If power absorbed by power absorbed by voltage source, if power absorbed by the voltage source, then I is how much? If power is absorbed by the voltage source, then I is how much? if power is absorbed by the voltage source, then I is how much? Okay, and I'm giving options here. If power is absorbed by the voltage source, then I is how much? Okay. If power is absorbed by the voltage source, then I is how much? Everyone. Yes, everybody. See, these are basic questions. Now, see, if R is 2, I is 5. See, he said if this R is 2 now, I is 5. Now if R is 5, I is how much? See, actually this resistance is redundant. Why? Because sir, whatever may be element here, any element in series to current, current is always constant. That means whether R is 2 or 5 or 100 or 1000 or 1 mega or 1 giga ohm, until here how much current will come? 10 only will come. Na? This side nothing changed. This side nothing changed. So whether R is 2 or 5 or 100, this branch current is always fixed by the current source. So current source in series to any element, current source in series to any element is constant current only. Current source in series to any element is constant current only. So current is always fixed. Whatever may be the R, so I should be again same. I should be again same. Now see, right side question is very interesting question. It is a concept question. If power is absorbed by the voltage source, then I is how much? If power is absorbed by the voltage source, then I is how much? See, if voltage source is absorbing power, if voltage source is absorbing power, current should enter positive. Na? If voltage source is absorbing current power, current should enter positive. Okay. If voltage source is absorbing power, current should enter how much? Current should enter positive. Yes, if voltage source is absorbing current should enter positive. That means out of 12 amperes coming from this side, some current is entering here. So this current should be less than 12. This current should be less than 12. So I less than 12, only one option. So it is a answer based, is option based question, sir. So clearly I is less than 12, which is how much? Yes, which is 1 ampere. Sorry, which is 10 ampere. In the options, only one option is less than 12 amperes. So answer is 10 ampere. Okay, na? Like that. It's a very, very simple but interesting bit. Okay, na? So here I am asking question, what is I? Okay, we'll take a break of half an hour. Everybody take a break of half an hour. 9:10, come back. Yes, everybody, welcome back. Please raise your hand. Can you listen to me? Yeah, thank you, sir. Thank you. Yeah, now we will continue. See, we are still doing the basics of DC, and I'm giving such logical problems which are very interesting. I'm continuing further with this IES bit. I want this current I, and look at this network here. This is E. This is 3R, 4R, 2R, 4R, 2R, 4R. This current in this 4R branch is 1 ampere, and now he's asking to find this current I in this 2 ampere stop branch. Very interesting. Find current I. Okay, find current I. Okay, everybody find current I. Then this is gate instrumentation. Wonderful question, please. What is current I again? This is 100 volt. 5 ohm, 4 ohm, 3 ohm, 2 ohm, 1 ohm, 1 ohm, 1 ohm, and 1 ohm. Now he's asking to find this current I. Chalo sir, everybody do very interesting bits. Everybody do this thing. Okay, find current I in both the cases. Yes, everybody look. See, he gave the hint, na sir. This now let us find this current I in the left circuit. But he gave hint. See, he gave a hint that this current in 4 ohm branch at the bottom is 4 R ohm. Okay, the current in this 4 R is not given. Here, interesting is this R is not given and the battery voltage E is also not given. But he gave a hint that this current in this 4 R ohm branch is 1 ampere. Chalo, I will apply simple fundamentals KCL KVL. Now, if 4R branch ohms is carrying 1 ampere, this is clearly 4R volts and current enter positive and passive elements. Now, because these two are parallel, if 4R is across 2R, if 4R is across 2R, this is also 2 amperes. Now, this is 2, this is 1, total 3 amperes. Total 3 amperes. But sir, interestingly, between this node and this is a single node. See, please understand, this entire thing is a single node. Yes or no? Between this node and this single node, all are parallel. Between this node and this single node, all are parallel. If this is 4R volts, this is also 4R volts. If this is 4R volts, this is also 4R volts. 4R by 4R, 4R by 4R is 1 ampere. 4R by 4R is 1 ampere. 3 amperes plus 1 ampere is how much? 4 amperes. 3 amperes plus 1 ampere is how much? 4 amperes. Now, 4 across 3R is 12R volts. 12R volts. Okay? Yes. Yeah, simple KCL KVL, 12R. Okay. Now you see, yeah, with this hint of 1, this is 4R volts. 4R by 2 are 2. So 2 plus 1, 3. Now between these two also 4R. Yes. 4R by 4R is 1 ampere. 1 plus 3, 4. 4 3s are 12R. Okay. Now with this, I'm happily writing a KVL like this, and like this. KVL in any part. So all voltages I'm writing. KVL, if you start from here, minus 12R volts plus 2I volts, okay, minus 4R volts equal to 0. Okay, this is 12I, 12I. Okay, now this I will be how much now? See, 2I is equal to, okay, 16R. I is 8R. I is 8. You know, I is 8R. Okay, so something like that, sir. So in terms of R only I got. Okay, because R is not given. If it is given, you will get the value of the current. Okay, na? Now, sir, I am going to the right side bit. Right side is more interesting. Everybody listen to the right side bit. See, right side is a ladder network, sir. Directly, no two elements are series, not parallel. Ladder. Of course, you can reduce it from source point of view, but it is a ladder. Now, here, if you want to find current I, mesh analysis, 4 equations, nodal analysis, so many equations, we will do like that, sir. Instead, I will apply fundamentals like KCL, KVL, and Ohm's law. Actually, I should find I, but I will go ulta. Let I be, now listen, sir, very carefully. Let I be 1 ampere. Let I be 1 ampere. If 1 ampere is going through 3, this is 3 volt. If 1 ampere is going through 3 volt, so 3 by 1, 3 amperes. Now this is 3 ampere, 1 ampere, this is 4 amperes. 4 3s are 12 volt. Yes or no? Now this is 12 plus 3, total 15 volt. Yes or no? Now 15 by 1, 15 amperes. 15 plus 4, total 19 amperes. Now 19 fours are 76 plus 15, 91 volt. This is 91 by 1, 91 amperes. 91 plus 19, 110 amperes. 110 into 5, 550 volt plus 91, 641 volt. So 641 volts, see 641 volts here will drive their 1 ampere. 641 volts here will drive their 1 ampere. Then 100 volts will drive how much? So this I is 100 by 641 amperes. See, sir, what I did is actually I am finding current by homogeneity, proportionality. I am finding current I by using homogeneity or proportionality. Actually, I am supposed to find a normal way like mesh and nodal, it will take hell of a time. So what I did, actually I should find I, but instead I started ulta by taking this I as 1 ampere. Actually, I should find I, but ulta I started. I took 1 in 2 plus 1, 3 volts. Now Ohm's law, 3 by 1, 3 amperes. Now 3 amperes plus 1, 4 amperes. Now again KVL, 4 3s are 12. 12 plus 3, 15 volts. 15 by 1, 15 amperes. Now 15 plus 4, 19. 19 4s are 76 plus 15 is 91 volts. 91 by 1, 91 amperes. 91, 19, 110 amperes. 550 plus 91, 641. 641 volts can drive 1. 641 volts can drive 1. So 100 is how much? 100 by 640. Okay, it is 100 by 640. Okay, now 100 by 640. Okay. Now I'm giving another question here. find total power absorbed by network. Find the total power absorbed by the network. One ohm, 2 ohm, 3 ohm, 4 ohm. This is 3 amperes. This is 5 amperes. This is 2 amperes. Okay, chalo. Find total power absorbed by the network. 2 minutes, sir. Everybody try this 2 minutes. Find total power absorbed by the network. Now see, he is asking total power absorbed by the network. But to find total power absorbed by the network, we need branch currents. He gave some currents which are not directly helpful, Now, first, if you apply KCL to this entire system, see, first, if you apply KCL to this entire network together, okay, all incoming currents equal to outgoing currents. Now, what are incoming currents? 5 plus 3, 8. So, outgoing also should be 8. Now. So, if incoming is 8, yes, outgoing also should be 8. So, automatically, this is 2. So, this has to be 6. Yes. But still, I need branch currents. So, let this be X. I will assume X amperes. Now, out of X2 went. So, this is automatically X minus 2. Now x minus 2 is added with 5. X minus 2 is added with 5. X minus 2 is added with 5. X plus 3. Okay, x plus 3 minus 6. X plus 3 minus 6. X minus 3. Okay, x plus 3 minus 6 is x minus 3. Okay. Okay, so now I can apply KVL also. See, because x is something which we don't know. Just substituting something for x is not the meaning there. You have to even satisfy law of conservation of energy. Law of conservation of energy means KVL. So if you write a KVL, starting from here, 1 into x plus 2 into x minus 2 plus 3 into x plus 3 plus 4 into x minus 3. Yes, plus 4 into x minus 3 equal to 0. Okay, 1 into x plus 2 into x minus 2 plus 3 into x plus 3 for 4 into x minus 3 equal to 0. 1, 2, 3, 4. 10x is equal to 4. Okay, this is 12. 14 minus 9. Okay, and see 1 into x, 2 into x minus 2, 3 into x plus 3 plus 4 into x minus 3. Okay, now from that you say 1, 2, 3, 4, 10x. This is actually 4 and 12, 16. 16 minus 9. Okay, yeah, 7 I think it is. Okay, see because this is minus 4, this is minus 12. So total minus 16, right side 16. And this is 9. So 16 minus 9. 7. So x is 0.7. X is 0.7 amperes. No substitute. No substitute. So this is clearly zero point 0.7. Now this is 0.7 minus 2 is minus 0.3. Minus 0.3 means 1 minus 1.3 means it's going up. Minus means ulta direction. Now this is clearly 3.7. 3.7 amperes. Okay. Now this is zero point 0.7 minus 3 is minus 2.3. Minus 2.3 up means 2.3 down. Okay, so this is correct. This is satisfying everything, satisfying KCL, KVL. Na? So now we got the branch currents. Now power absorbed is I square or sigma square R. That is 0.7 square into 1 ohm plus 1.3 square into 2 ohm plus 3.7 square into 3 ohm plus 2.3 square into 4 ohm. That many watts. That many watts. Okay, so that answer you do it later, sir, but I'm just giving you the concept. Okay, so now this is another wonderful question. Yes, this is another wonderful question. See, I'm doing so many numerical problems, sir. The secret of this subject is tremendous practice. Once you practice, you'll get everything. Now determine, chalo, determine all branch currents. Determine all branch currents. See, this is my question. Determine all branch currents. Okay, now this is the question. This is 1 ohm, 2 ohm, 3 ohm, 4 ohm, 5 ohm, and this is actually 6 amps. Okay, determine all the, it is connected to some part of a network. Okay, but yes, determine all the branch currents. 2 minutes, everybody. Here, determine all the branch currents. Everybody please understand, determine all the branch currents. Okay, now in this regard, actually, this is a bridge structure. Okay, this part is a bridge structure. But you know, in a bridge structure, no two elements are either series nor parallel. Yes or no? No two elements are either series nor parallel, and it is not balanced, nor symmetry, nor current division, nor voltage division. So in such case, nothing can be done. Again, we rely on fundamentals like KCL, KVL, and Ohm's law only. See now, again, see, let this be x amperes. Out of 6, x went. So this has to be 6 minus x. Now x came here. Again, these two are neither series nor parallel nor symmetry. So out of x, let us say this is y. So this becomes x minus y. Now KCL. See, this is 6 minus x and y. So total this is 6 minus x plus y. Now this is 6 minus x plus 5 plus x minus y is again 6. Is again 6. Is again 6. Now happily I can write KVL here. Happily I can write KVL. Because 2 unknowns, 2 KVL. KVL 1. Okay, 2 unknowns, 2 KVL. 1 into x plus 3 into y minus 2 into 6 minus x is 0. Okay, 1 into x plus 3 into y minus 2 into 6 minus x is 0. Now KVL 2. KVL 2, if I say this is 4 into x minus y, this is minus 5 into 6 minus x plus y minus 3y equal to 0. Okay, now solve and find. Okay, solve and find x and y. Okay, now solve and find x and y. Okay, now please understand. Solve and find x and y. Okay, after solving x and y, substitute here. So this is x, this is y, x minus y. Like that, you can substitute. Okay, substitute. Okay, that is the answer. Okay. So that is the answer. So that part you do, but fundamentals. Chalo now, sir, if all problems are so simple, we would have done like that. If all problems are so simple, we would have done like that. But now I am going to chapter 2. See, chapter 1 is so big, but chapter 2 is very, very small but powerful. That is methods of analysis. Methods of analysis. Now here, if all problems are so simple, now, sir, we would have done in simple KCL, KVL like that. So many problems we did since yesterday, but if all problems are so simple, then we would have done like that. But there are so many problems where direct reduction not possible, KCL, KVL also is very tough. Then in such case, what to do? Methods of analysis. Now, what are these methods of analysis? Yes, one is mesh analysis. One is mesh analysis. Okay, mesh analysis is a systematic way to solve the network by using KVL and Ohm's law. KVL and Ohm's law. Okay, KVL and Ohm's law. Okay, then second is nodal analysis. Nodal analysis is a systematic arrangement. Yes, nodal analysis is a systematic arrangement to the network by using KCL and Ohm's law. KCL and Ohm's law. Okay, mesh analysis is systematic arrangement to the network by using KVL and Ohm's law. Nodal analysis is systematic arrangement to the network by using KCL and Ohm's law. Okay, KCL and Ohm's law. Okay, na? Both are superior, both are powerful, but we already learned basics, na sir. Mesh analysis require planar arrangement in the network. Planar arrangement in the network. That is a requirement. Now both are superior, both are powerful. I told you such bits like which is faster and when. But general observation is yes. If there are more current sources and less voltage sources, including dependent sources. Okay, including dependent sources, mesh is faster. Similarly, if there are more voltage sources but less current sources, yes, if there are more voltage sources but less current sources, then nodal is faster. Okay, na? Chalo sir, model number 1. Model 1. Everyone should listen. Model 1. Find V by using mesh and nodal analysis. Mesh and also nodal. Okay, na? This is my first bit. Okay. See, we will use them when necessary, sir. We will definitely use them when necessary. Very, very important for us. Okay. Find V by using mesh and nodal analysis. So this is 10 volt. This is 2 amperes. This is 1 ohm, 1 ohm, 1 ohm, and this is 2 ohm. And this is the V is asking. Find V by using mesh and nodal analysis. Okay. Find V by using mesh and nodal analysis. Okay. Find V by using mesh and nodal analysis. Okay, na? Yes. Find V by using mesh and nodal. Excuse me. Now see, first in mesh analysis, how many meshes are there? 3 meshes. So I will take clockwise I1 clock, I2 clock, I3 clock. Of course, mesh currents are closed path currents. Now to find V, which is a voltage across 2 ohms, to find V, which is a voltage across 2 ohms, which is the external branch of mesh 3, I will find I3 because V is 2I3. Okay, to find V, which is a voltage across 2 ohms, okay, I will find first mesh current I3. So V is 2I3, like that. Okay, now V is 2I3. Okay, now, so in that regard, yes, everybody in that regard, if I start here, yes, in that regard, if I start here, starting from here, yes, minus 10 plus 1 into I1 minus I3 plus 1 into I1 minus I2 is 0. See how I'm going here, starting here, sir. See 1 into, so first minus 10, clockwise now, first minus 10, 1 into, now this branch current is the difference of these two mesh currents now, but because I'm forcing to go clockwise, I1 should dominate I3. I am forcing current to go clock. So I1 should dominate I3. So 1 into I1 minus I3, and here also 1 into I1 minus I2 is 0. So 2 I1 minus I2 minus I3 equal to 10. This is the first. Okay, now second mesh. Now second mesh, if I try to write, okay, this is 1 into I2 minus I1, this is 1 into I2 minus I3, but there is a current source now. We need voltage here because we are writing KVL. Okay, in mesh analysis, we are writing KVL. But to find, yes, in mesh analysis, we need to find voltages, but it is a current source. We don't know right now the voltage across current source. Okay, we don't know right now the voltage across current source. So in such case, comparison equation you write. What is the comparison equation? I took current I2 clockwise. I took current I2 clockwise. So already in this branch, I took current I2, but actual current is 2 amperes opposite to my direction. Now. I took I2 clock, but actual current is opposite to my direction. So I2 is minus 2. I2 is minus 2. I2 is minus 2. Now if I start third, this is 2I3 plus 1 into I3 minus I2. Okay, 1 into I3 minus I2 plus 1 into I3 minus I1 is 0. Okay, 2I2 plus 1 into I3 minus I2 plus 1 into I3 minus I1. So minus I1 minus I2 plus 4I3 equal to 0. Okay, minus I1 minus I2 plus 4I3 equal to 0. Okay, now this is minus I1 minus I2 plus 4I3 equal to 0. This is the third equation. This is the third equation. Okay, so observe, sir, how I am writing equations. Now solve them, sir. Let me solve this. See, finally my challenge is to find V. V means I3 I should know, na? So if you substitute, if you substitute first I2 in both case, 2I1 minus I3, okay, equal to 8. And this is minus I1 plus 4I3 equal to minus 2. Minus 2. So 2 times you multiply here again. This is minus 2I1, okay, plus 8I3 equal to minus 4. Now if you add, yes, 7I3 equal to 4. I3 is 4 by 7. So if I3 is 4 by 7, now so finally V is 2I3. Because you see Ohm's law, V is 2I3, now this is 2 now, 2I3. So that is 2 into 4 by 7. Answer is 8 by 7 volt. 8 by 7 volt. 8 by 7. Everyone observe how I wrote the mesh equations. Everyone please observe how I wrote the mesh equations. Please observe. Everyone observe how I wrote the mesh equations. So many are giving answers, sir. Very good, sir. How current is VO by 2? Okay, doubts I will take up at the last. Very good, sir. I'm happy that see so many are giving answer. So many, very good, sir. Very good. That is what I want. Take pen, paper, sit along with me and keep doing. Because this subject will get only like this, sir. Understand? Why I do so many problems in the class? Practice. Once you get practice, network theory, they say network theory, but in this theory is not there anywhere. Final answers I don't know because some problems I just designed like that. Final answers I don't know, sir. Okay, na? Final answers I don't know. Don't worry. But okay, some calculations I left to you. Okay, na? Yes, some calculations I left to you. I2 is minus 2 because see, actually I should write KVL here, but voltage across current source is still not defined. There is a comparison because I took this mesh current already I2. See, this mesh current is branch current in external branch. I took already clockwise I2. But actual current in this branch is coming opposite to my reference now. I2 is minus 2. I2 is minus 2, like that. It is a comparison equation when current source come. So now I will do the same thing by nodal. Same problem. Find voltage V by using nodal analysis. So this is 1 ohm, 1 ohm, 1 ohm. This is 2 ohm. This is 10 volts and this is 2 amperes. And I need this voltage V. Okay, I need this voltage V by nodal analysis. Okay, I need this voltage V by nodal analysis. Okay, everybody, I need this voltage V by using what? Nodal analysis. Okay, now nodal analysis, voltage V by nodal. Now here, there are total 4 nodes. 1, 2, 3, and 4. There are total 4 nodes and all are principal nodes. Okay, there are total 4 nodes and all are principal nodes. Okay, but one of the principal node I will take it as reference. Okay, and let this be V1, let this be V2, let this be V3. So V is the voltage across 2 ohms branch. V is the voltage across 2 ohms branch, but this branch is connected between V1 and V3. And because this is more positive than this, V is V1 minus V3. Chalo, V is V1 minus V3. Now in nodal, we should write KCL. But lucky that, see here also lucky that V1 is directly subjected to 10 volts with respect to ground. V1 is directly subjected to 10 volts with respect to ground. So V1 is 10. V1 is 10. Second equation, KCL. See, first equation I need not write KCL because V1 I directly got, because V1 is directly 10 volts with respect to ground. But here if you write KCL, now my notation is whenever I write KCL, I assume that node is at highest potential. Okay, that is my notation. I take a notation that node is at highest potential. If this node is at highest potential, all currents leave. If this node is at highest potential, all currents leave. So this current is V2 minus V1 by 1. This current is V2 by 1. And this current is V2 minus V3 by 1 equal to 0. Okay, by 1 equal to 0. So 3V2, of course V1 is 10 now. Okay, 3V2 minus V3 equal to 10 because V1 is 10. See, this current plus this current plus this current is 0, sir. V2 minus V1 by 1, V2 by 1 because this is 0, V2 minus V3 by 1. Third, if I write, this is minus 2 plus V3 minus V2 by 1 plus V3 minus V1 10 by 2 equal to 0. So minus 2V2 plus 3V3 equal to 14. 14. Okay. Minus 2V2 plus 3V3 equal to 14. Equal to 14. Now to find V, I need V1 and V3. V1 I already know. So let us find V3. Now from this equations, let us solve V3. Sir. For that, what I will do is, first equation I will multiply by 2. That is 6V2 minus 2V3 equal to 20. And third equation, second equation I will multiply by, let me take this as second. Let me correct. Second equation I will multiply with 2. Third equation I will multiply with 3. So minus 6V2 plus 9V3 equal to 40. Now if you add, yes, 7V3 equal to 62. V3 is 62 by 7. Then I can write. V is V1 minus V3. V1 is 10. 10 minus 62 by 7 is again 8 by 7 volts. See, sir, we got same answer. 8 by 7 volts. See, previously also 8 by 7 volts. 8 by 7 volts. Look at the equations, everybody. Look at the equations. Okay, everyone observe. So I'm going to model 2. Everyone see, sir, model 2. Now here in model 2, yes. Now I'm asking find current. Chalo, find current I again by using mesh and nodal analysis. Mesh and nodal analysis. Okay, na? So this is the next model. Let us understand why it is special here again. But after understanding these basics, I am going to expand like anything, sir. Initially, my subject looks like this. Then now after these basics are over, aggressively I will go. And that time, if you are getting doubts, means you are not good in basics, and not good in basics, I cannot help. So that is why, sir, fundamentals are always fundamentals. We say base foundation course we call. If foundation is strong, any level we can reach. That is my belief. Foundation is strong, any level we can go. Chalo, now everyone find current by using mesh and nodal. Find current I by using mesh and nodal analysis. Find current I by using mesh and nodal analysis. Okay, now everybody. Okay, find current I by using mesh and nodal analysis. Now here again first mesh analysis. If I go to mesh analysis, yes, this is current I1, this is current I2, and this is current I3. So first if I write the mesh equations, yes, first if I write the mesh equation starting from here, yes, this is minus 10. Okay, now this is 1 into I1 minus I3. This is minus 10, 1. But now suddenly current source came. This time current source is a common branch between two meshes. This time current source is a common branch between two meshes. So in such case, treat it as an open circuit. Treat it. Actually, it is not open circuit because the internal resistance of ideal current source is like infinity. Yes, because the internal resistance of ideal current source is like infinity. I treat it like open circuit. So minus 10, 1 into, yes, I1 minus I3. Now jump here because it is a current source. We right now don't know the voltage across it. There will be some voltage across it, which I don't know. That is why I'm unable to write KVL across this. So I went to minus 10, 1 into I minus I3. Now when current source come as a common branch, now jump to second mesh automatically. Now come here. Now continue KVL. What is the KVL here now? Yes, this is 1 into I2 minus I3. This is 1 into I2 minus I3. And finally 2I2. Finally 2I2 equal to 0. Okay, minus 10, 1 into I1 minus I3, open and KVL here, 1 into I2 minus I3 plus 2I2 equal to 0, 2I2 equal to 0. So this is called super mesh. Why it is called super mesh? Yes, whenever current source come as a common branch between two meshes, it is called super mesh. Whenever current source come as a common branch between two meshes, it is called super mesh. Yes, whenever current source come as a common branch between two meshes, it is called super mesh. Open and write KVL. So minus 10, 1 into I1 minus I3, yes, 1 into I2 minus I3 plus 2I2 equal to 0. So if you first simplify, I1 plus 3I2 minus 2I3 equal to 10. Equal to 10. Okay, na? Yes, I1 plus 3I2. Okay, yes, I1. Everybody, okay? I1 plus 3I2. Okay. Okay, and this is 2I2 equal to 0. Is that okay? So now second, see we started in the first mesh, everybody. Yes, we started in the first mesh. We also wrote the KVL including second mesh. Why? Because it is called super mesh. What is super mesh? Whenever current source comes as a common. See in the previous model, where was the current source? It was in the external branch. There is only comparison that I2 is minus 2. But here what happened? Current source came as a common branch. Actually, we are writing voltages. Na? Chalo, now in that case, open and write KVL. That is called super mesh. Okay, na? Now once you write KVL, super mesh, now the second equation is the difference equation. Why? Because we started here, we wrote even for the second. Combined KVL for two meshes is over, sir. That is why it's called super mesh. That is why it's called what? Super mesh. Now the second equation is the difference equation. What is the difference? See, I1 clock, I2 clock. I1 clock, I2 clock. But the resultant is going up. Na? Resultant going up means I2 should be greater than I1. So I2 minus I1 is 2. I2 minus I1 is 2. Okay, na? I2 minus I1 is 2. Okay, na? Yes. Now third is directly 1 into I3 plus 1 into I3 minus I2. Yes, plus 1 into I3 minus I1 is 0. Okay, na? 1 into I3, 1 into I3 minus I2, 1 into I3 minus I1 is 0. Okay, so minus I1 minus I2 plus 3I3 equal to 0. So from this 3, I need I, sir. But I is I2 na. Because I is the current flowing in 2 ohms branch. I is the current flowing in 2 ohm branch. I is the current flowing in 2 ohm branch, which is the external branch of mesh 1. The external branch of mesh 1 is I2 only. Sorry, external branch of mesh 2. Let me correct it. See, I is the current flowing through 2 ohms, which is the external branch of mesh 2. So I is I2. I is I2. So from these two, let me solve, sir. First, I will add 1 plus 2 equations. 4I2 minus 2I3 equal to 12. Then I will add 1 plus 3. If I add 1 plus 3, yes, this is 2I2. Okay, 2I2 plus I3 is 10. Plus I3 is 10. Now I need I2 na. So 2 times and add. If you make this 2 times, 4I2 plus 2I3 equal to 20. Now add these two. So now if you add these two, yes, that is nothing but 8I2 equal to 32. Yes, 8I2 equal to 32. So I2 is 4 amperes. I2 is 4. That implies automatically I is 4 amperes. Because I is I2 na. I is 4 amperes. I is 4 amperes. Yeah, I is 4 amperes. Okay, na? So I'm doing the same problem by nodal. Now by nodal. See, same problem by nodal analysis. Now nodal is straightforward, sir. Everybody look at nodal equations, what I'm writing. Again, I need current I by nodal. Okay, now let me take the remaining network as it is. This is 1 ohm, 1 ohm, 1 ohm. This is 2 ohms, 10 volts, and 2 amperes. This is I. This is I. Okay, this is 10 volts, 111. This is 2 amperes, and this is I. Okay. So again, I need to do this by nodal. Now there are total 4 nodes. All are principal nodes with degree greater than 3. So if I take reference, this is V1, this is V2, and this is V3. Okay, yes, this is V3. Okay, so now if I write nodal, V1 is directly 10. V1 is directly 10. Okay, now second equation. See, this is V2 minus V1 by 1. This is minus 2 plus this current right side is V2 minus V3 by 1 equal to 0. So this is 2V2 minus V3 equal to 12. That is second because V1 is 10 only. KCLs are KCL at this junction. All currents leave. My notation is current leaving. Sum of currents leaving at junction is 0. All currents. Okay. Chalo. Now third equation V3 by 2. Okay. This current V3 by 2 plus this is V3 minus V2 by 1 plus this is V3 minus V1, but V1 is 10 now, 10 by 1 equal to 0. So minus 2V2 plus 5V3 equal to 20. But I need I. But I need I. I is the current flowing in 2 ohms. I need I. I is the current flowing in 2 ohms. But that branch current is V3 by 2 only. So let us solve V3. If you add 2 and 3, if you add 2 and 3 directly, 4V3 equal to 32. So V3 equal to 8 volts. If V3 equal to 8, I is V3 by 2, that is 8 by 2, 4 amperes. 8 by 2, 4 amperes. Okay, 8 by 2, 4 amperes. Okay, yes, it is 4. So same answer we got here also, there also, yes, 4 amperes. Now I'm going to model 3, which is more interesting, model 3. Okay, yes, now I'm asking determine, let's determine, okay, determine power delivered, power delivered by voltage source. Determine power delivered by voltage source by using mesh and nodal. Okay, by using mesh and nodal analysis. Okay, determine power delivered by the voltage source. I will write here voltage source by using mesh and nodal analysis. Okay, determine the power delivered by the voltage source by using mesh and nodal analysis. Determine power delivered by the voltage source by using mesh and node analysis. Okay, determine the power delivered by the voltage source by using mesh and nodal analysis. Determine power delivered by the voltage source by using mesh and nodal analysis. Okay, now determine power delivered by the voltage source by using mesh and nodal analysis. Okay, now in that regard, everybody. First, I will do mesh equations. Okay, as usual, I will do mesh equations. Okay, everybody, as usual, I am first doing mesh equations. Okay, chalo. Mesh current I1, mesh current I2, mesh current I3. Now here also super mesh came because current source is there. Na? Chalo, now I am writing the equations. First 1 into I1 plus 1 into I1 minus I3 plus 10 plus 1 into I2 equal to 0. So 1 into I1, 1 into I1 minus I3, open, plus 10 plus 1 into I2. So this is 2I1 plus I2 minus I3 equal to minus 10. Okay, 2I1 plus I2 minus I3 equal to minus 10. Okay, now second equation is the difference. This is I1, this is I2. This is I1, this is I2, but difference is going up now. So I2 should dominate I1. So I2 minus I1 equal to 15. Third, directly 1 into I3 minus 10, 1 into I3 minus 10 plus 1 into I3 minus I1 equal to 0. Minus I1 plus 2I3 equal to 10. Equal to 10. Okay, because first is again super mesh. So 1 into I1, 1 into I1 minus I3. Yes, this is plus 10 plus 1 into I2. Then difference I2 minus I1 is 15. Okay, and third is normal. But from these three, I want what power delivered by voltage source. See, to find the power delivered by voltage source, I need this branch current. Na? To find the power delivered by this voltage source, I need the branch current. But this branch current is the difference of these two mesh currents, I2 and I3. See, to find the power delivered by the voltage source, I need to find this branch current. But this branch current is the difference of these two mesh currents. So first, let us find both I2 and I3, and then we'll find the branch current and direction also. So let us find I2 and I3. Okay, I am finding both I2 and I3. Now, if I try to solve, okay. Yes, if I try to solve, okay, first 1 minus 2, equation 1 minus equation 2, if I take 2I1, okay, 3I1, this becomes now 3I1, yes, 3I1, okay, and this is 0, this is minus I3 equal to minus 25. And here directly, if I take minus 3I1 plus 6I3 equal to 3 times 1, 30. So if you add these two, 5I3 equal to 5. I3 is 1 ampere. I3 is 1 ampere. Yes, I3 is 1 ampere. Yeah, I3 is 1 ampere. Okay. Chalo, if I3 is 1 ampere, if I3 is 1 ampere, I1 is minus 8. If I3 is 1 ampere, I1 is minus 8. If I1 is minus 8, okay, if I1 is 7 ampere, I2 is 7 amperes. I2 is 7 amperes. So now with this information, I'm writing the conclusion in the next page. See, I need the power delivered by this voltage source. See, this branch I'm writing separately, this 10 volts. Okay, this 10 volts. But I got both I2, I3. See, I2 I got how much? 7. Plus 7 means what? Plus 7 means what? Clockwise 7 amperes. And I3 how much I got? See, I3 how much? Plus 1. Plus 1 means this is also clock 1. Now the difference of current. See, right side going 7. Clockwise this is 1. So difference is how much? 6 amperes centering positive. See, this is clockwise 7, clockwise 1. Difference is how much? 6 amperes centering positive. If 6 amperes centering positive is source or sink? Sink. 6 amperes entering 10 means it is sink. So power delivered. Sink cannot deliver, na? Minus 6 into 10. Minus 60 watt. Minus 60 watt. Everyone observe the equations. I will tell you the conclusion again. Okay. See, after getting this both I2 and I3, now the branch current in 10. See, I2 I got plus 7, so clockwise 7. I3 I got plus 1, clockwise 1. But the difference is 6 ampere centering positive. Now it is a sink. Power delivered is negative. How can sink delivers are meaningless? Na? So power delivered is negative like that. Okay, na? So I am doing the same problem by nodal. Now what is special in nodal? Let us see, I am doing the same problem in nodal. Same by nodal. Something special here. Let us observe what is that special thing we can learn here. So this is 1 ohm, 1 ohm, 1 ohm and 1 ohm. Okay, this is 15 amperes. And this is 10 volt. Okay, this is 1 ohm, 1 ohm, 1 ohm. This is 15 ampere and 10 volt. Okay, so I need power delivered by voltage source by using nodal here, by using nodal. So this is principal node 1, principal node 2, principal node 3 and principal node 4. Okay, but out of all principal node, I will take one as reference. I will take one as reference. Okay, let this be V1, let this be V2, let this be V3. So I am writing the nodal equations first. Now first equation. Now this time V1 is not directly available. So this current plus this current plus this current is 0. That is V1 by 1 plus V1 minus V2. Okay. Yes, V1 minus V2 by 1 plus V1 minus V3 by 1 equal to 0. So 3V1 minus V2 minus V3 equal to 0. Okay. 3V1 minus V2 minus V3 equal to 0. Okay. Now if I go to the second, yes, if I go to the second equation, this current plus this current plus this current is 0. This is V2 minus V1 by 1. This is minus 15, but this current I don't know. Now. See, this current I don't know. This current I don't know. But this current is sum of these two currents because there is a voltage source here. Whenever you see ideal voltage source between two principal nodes, it is called supernode. So in that case, what to do now? Supernode. Now listen here. In that case, what to do? See, actually, this current is V2 minus V1 by 1. This current is minus 15. But this current I don't know. Nah. That current only I need to find in fact. But because there is an ideal voltage source between two principal nodes, it is called supernode. So instead, this current is this current plus this current. So what is this current? Yes, what is this current? V3 by 1. V3 by 1. And what is this current? V3 minus V1 by 1. V3 minus V1 by 1 equal to 0. So V2 minus V1 by 1 minus 15. Shoot it. V3 by 1. V3 minus V1 by 1. So this is minus 2V1. Okay. Plus V2 plus 2V3 equal to 15. This is called supernode. This is called supernode equation. So what is supernode? Whenever there is an ideal voltage source between two principal nodes, whenever there is an ideal voltage source between two principal nodes, okay, yes, we shoot through and write the KCL. So V2 minus V1 by 1 minus 15. This we don't know, shoot it. So V3 by 1, V3 minus V1 by 1. Okay, so minus 2V1 plus V2 plus 2V3. Yes, minus 2V1 plus V2 plus 2V3 equal to 15. Now I'm writing the third equation. Now see whether you start at V2 or start at V3, we'll get this equation only. Whether you start at V2 or start at V3, we'll get this equation. Then what is the difference equation? See, V2 is more positive than V3 by 10. V2 is more positive than V3 by 10. So V2 minus V3 is 10. So from this 3, first let us solve, sir. From this 3, let us solve. Now if you observe carefully, first equation into 2. Okay, 6V1 minus 2V2 minus 2V3 equal to 0. Second equation into 3. Second equation into 3 is minus 6V1 plus 3V2 plus 6V3 equal to 45. Now if you add V2 plus 4V3 equal to 40. Okay, now if I add these two also, so this and this if I add further, okay, or subtract, okay, subtract this minus this if you subtract 5V3 equal to 35. V3 is 7 volts, okay. Once V3 is 7, calculation you do it, sir, don't worry. So once V3 is 7, V2 is 17 volts, okay. Once V3 is 7 and V2 is 17, so this becomes 24 by 3. V1 is, okay, 8 volts. So now I'm doing the conclusion. See, we got this voltages, but I need the power delivered by the voltage source. Now, see now carefully. This is how much he gave, 15 amperes. This is 10 volts. Now we got this answers, sir. Chalo, V1 how much we got, sir? V1 how much we got? V1 is 8 volts. Okay, V1 is 8 volts. This is the node voltage with respect to reference, please. And V2 how much we got? V2 17 volts. Now this is 17 volts. 17 volts. And finally V3 how much? 7 volts. V3 is 7 volts. 7 volts. Okay, now. So V1 is 8 volts, V2 17, V3 7. But to find the power delivered by this voltage source, I need this branch current. Now see, this is 17, this is 8. Now listen, this is 17, this is 8. This current is potential difference by path resistance. Huh? Yes, this current is potential difference by path resistance. Of course, path resistance is 1. So this is 17 minus 8 by 1 is 9 amperes. Now apply KCL. Now apply KCL. See, out of 15, 9 went. Out of 15, 9. This is 6. Out of 15, 9 went. This is 6. But this current is entering positive. It is saying, I applied KCL, sir. Here I applied KCL. After getting the node voltages, now, sir, I got this branch current because 17 minus 8 by 1 is 9. Out of 15, 9 went. So 6 has to go like this, KCL. But current is entering positive. It is a sink. So power delivered. It's negative voltage into current. Answer is minus 60 watt. Answer is minus 60 watt. Okay, now please understand. So here also we got same answer now. Here also we got same answer now. So finally it is a sink. Okay, finally it is a sink. And you know, yes, power sink cannot deliver power. Power delivered is, yes, negative. Because if it is a source, power delivered is positive. But it is a sink, power delivered is negative. Okay, now. So now I'm giving a practice problem. I want everyone to quickly write these equations. Okay. Okay, determine power absorbed by 3 Siemens conductance, okay, by using mesh and nodal analysis. Okay, determine the power absorbed by 3 Siemens conductance by using mesh and nodal analysis. Determine the power absorbed by 3 Siemens conductance by using mesh and nodal analysis. So this is like 10 volts, 2 Siemens, 3 Siemens, 1 Siemens, 5 Siemens, 4 Siemens. This is like plus and minus 8 volt, and this is like 6 amperes. Okay, everybody look at this question. Determine power absorbed by 3 Siemens. Okay, determine power absorbed by 3 Siemens. Where is the 3 Siemens? Here it is. Okay, determine power absorbed by 3 Siemens by using mesh and nodal. Okay, sir. See, you need not do full calculations, only write mesh and nodal equations. So I will give you the notations. Now everybody see here, total how many nodes are there? 1, 2, 3, 4, 5, 6. Total nodes are 6, but we neglect simple nodes. Okay. Now first in mesh analysis, 3 mesh currents, I1, I2, I3. Okay. In nodal, though there are 6 nodes, 2 nodes are simple neglect, but one principal node I take reference and let this be V1, let this be V2, and let this be V3. Sir, you just write mesh and nodal equations, sir. Don't calculate. I only want you to write mesh and nodal equations. Everybody just write mesh and nodal equations, nothing. Please write mesh and nodal equations, everybody. See, this session may look boring, but sir, you are good in mesh, very good, sir. But see, yes, some students say they are very good in mesh and model, but it is my duty to teach. But after this, only the real things will come, sir. Yeah, see, first I'm writing the mesh and model equations. Now, if I look at the mesh and model equations, yes, in mesh, because it is conductance, na, sir, I, that is V is I into G or I difference into G. Yeah, in mesh, sorry, in mesh, you write voltage, na, V is I by G or I difference by G. So I'm starting from here. This is I1 by 2, okay, minus 10, okay, and this is what I1 minus I3, I1 minus I3 by 3, okay, this is I1 minus I2, okay, I1 minus I2 by 1 equal to 0, okay, I1 by 2 minus 10, I1 minus I3 by 3, I1 minus I2 by 1, okay, then here if I write KVL, yes, if I write KVL, I2 minus I1 by 1, okay, this is now again I3 minus I1, I3 minus I1 by 3, and this is I3 by 4, okay, plus 8, okay, plus I2 by 5 equal to 0. Super mesh equals, yes or no? Okay, I2 minus I1 by 1, I3 minus I1 by 3, I3 by 4, plus 8, plus I2 by 5. Third is the difference, see, I3, I2. So I3 minus I2, let me correct it. I3 minus I2, because this current is going left side, so I3 should dominate. I3 minus I2 is 6. Okay, now from this 3, Nasar, solve both I1 as well as I3, because I need power now. Now power in 3 Siemens will be, okay, difference of current square by G, not I square R. I1 minus I3 square by G. G is how much? 3, that many watts. Okay, look at this. Any doubt, I will tell you after this problem. Look at this, sir. Look at this. Anyone? Look at this. Okay, that calculation I'm leaving to you, sir. You do it, calculation. Now let me do the same problem in nodal. Everybody, let me do the same problem in nodal. So in nodal also, if I write, everybody just look here. If I write the same problem in nodal, this is 10 volts, this is 2 Siemens, this is 5 Siemens, this is 1 Siemens, 3 Siemens, 4 Siemens, 6 amperes, 8 volts. Okay. So now nodals are first. Again, there are total 1, 2, 3, 4, 5, and 6. Out of 6, simple nodes I neglect. But one of the principal node I will take as reference. So let this be V1, let this be V2, let this be V3. Okay, let this be V1, V2, V3. Okay, I'm now writing the nodal equations. Okay, KCL. Nodal equations is nothing but KCL. Okay, na? Chalo, in that regard. Now, node voltages. Okay, here I is V into G or V difference into G. See, first this current. This current will be V1 minus 10 whole into 2, because this current is potential difference into branch conductance. So V1 minus 10 into 2. This is, yes, V1 minus V2 into 3. Yes, V1 minus V2 into 3. But this is interesting. V1 minus V3, I'm writing here, see, V1 minus V3, but you are going against the force, na? Against the force, because your direction you are taking right side. But this voltage source generally has the ability to drive charge from the positive terminal. But you are going against the force. So V1 minus V3 minus 8 whole into 4. Minus 8 whole into 4. Because current is potential difference into path conductance. V1 minus V3 minus 8 whole into 4 equal to 0. Second equation. This is simple, 3 into V2 minus V1. This is 1 into V2. This is minus 6 equal to 0. Okay. And this is 5V3. Okay. This is plus 6. And this is 4 into V3 minus V1 plus 8 equal to 0. Okay. This is 5V3 plus 6 plus 4 into V3 minus V1 plus 8 equal to 0. Okay. Now from this 3, solve to find V1 and V2. Okay. Then power, yes, power absorbed by 3 Siemens is Okay, V1 minus V2 square, not V square by R, it is V square into G, the units. Okay, look at this. Okay, look at these equations are. Now, dependent models are there. We will continue that tomorrow. And after that, the real big things. So tomorrow onwards, class will be very interesting, sir, because we are going to start theorems. So now you can ask doubts. Yes, anyone doubt, please ask. Shiva, what is your doubt?
So previous round, sir.
Tell me.
Sir, here why can't we ground that V3 node, sir, instead of going for super node?
You can do absolutely true. Yes, you can do. If you ground V3, you can take this as V1, V2, V3, then you can apply KCL here. Answer will come same, nothing wrong.
Yes, sir. I don't know how to apply those equations when I ground V3, sir.
No, if you ground V3, suppose just listen. If you ground V3, this V2 itself will become 10 na?
Yes.
Then this V1 becomes, suppose this is V3. Instead of ground, this is V3, let us say.
Okay, sir.
So this is V1 minus V3 by 1, V1 by 1, V1 minus V2 by 1.
Okay, so then what about the current in the 10 volt?
Apply KCL. Again, what you have to do, you have to find V2 is already 10. You have to find V1. Then you should find the branch current here and apply KCL to find the branch current here.
Oh, okay, sir. Correct, sir.
Okay, you will get it. You do it. 100% you will get it. Okay.
Yes, sir. Okay, sir. Yes, sir.
Yeah.
Thank you, sir. That's it.
Yeah. Kushal, what is your doubt?
Hello, sir. In the first, today starting at the fourth or fifth question, the middle is the current source and either side is the voltage source.
Wait, I'm coming there. Which one can you explain?
Middle in the current source.
This one?
No, sir. Middle in the current source and other side.
Tell me.
This, sir. Sir, here you have taken Vx plus 2 in the last
KCL.
branch.
KCL.
So yes, sir. But the current source should be not delivered to the 10 volt. It is not divided into two branches.
No. I'm never declaring yet. We are not declaring anything yet here. We are not declaring anything. See, according to Ohm's law, we are first satisfying KCL and KVL. This is Vx by 1. This branch current already we took Vx na.
Yes.
This is 2. So this branch current is already Vx and this is 2. So KCL incoming currents equal to outgoing currents. But actually 2 amperes may divide, but we can find later once we know Vx na.
So it is not divided, no?
It is understood that it is not divided. See, it all depends upon, suppose you do nodal analysis. See, the best thing is to remove confusion. You take this as reference node and find the node voltage here. Then if this node voltage is less than 10 volts, then this current is already decided by this voltage source only.
Okay.
Actually, we cannot declare anything because there are multiple source networks. If it is a pure passive elements, then your argument is very straightforward. Because if passive elements are there, we know current will pakka divide.
Okay.
But here it depends. See, because active elements are also there, it depends.
Okay, so we have to take on only simple means.
We are satisfying KCL, KVL, but after solving, if it is really dividing, we will get. Suppose imagine I got Vx negative. If Vx was negative, not positive, then it is understood that this current source is contributing some current this side.
Okay.
Okay.
Sir.
Okay.
And so in the last question.
Yeah, tell me.
Sir, the voltage equation is that V1 plus 10. Sir, V1 plus 10 should be there.
No. This branch current I am writing. This branch current is potential difference into path conductance.
So the V1 plus 10 by into 2 is not coming.
No. This current I am writing. Current is potential difference into path conductance because I am taking all currents leaving as positive. So
okay.
V1 minus 10 into 2. This is V1 minus V2 into 3. This is V1 minus V3 plus minus 8 whole into 4.
Okay. Yes, sir.
We are satisfying notations of KCL, KVL. Then after solving, answers will tell whether it is correct or not, greater or less. All this KCL, KVL mathematical solution will take care.
Okay.
Yes,
sir.
Okay, right. Okay, now Ramakrishna.
Yes, hello. Good morning, sir.
Tell me.
Sir, you have given these three models, no, sir. In future, will there be any shortcuts to do, or is this the only way?
What?
You have given the three models of this, no, sir, in the above.
Ah.
So in future, will there be any shortcuts, or only only in this way?
No. These are the basic three models I covered. We are going to expand a lot tomorrow.
Okay, sir.
Okay.
By using theorems, more easy.
More powerful things will come.
Okay.
When dependent source I should start first, then theorems I will start. Okay.
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 Okay. Thank you.
Yes. So tomorrow everybody 7 o'clock.